In this video, I'm going to show you a couple of different ways you might use to find the rule of an absolute value function. Depending on the information you're given, you may need to combine these three strategies. First of all, let's remember that the rule of an absolute value function looks like this. Y equals A times the absolute value of B times x minus h, end of absolute value, plus k. Now, when we're finding the rule of an absolute value function, we can use a simplified version. And that simplified version looks like this. Y equals A, absolute value of x minus h plus k. In this simplified version, the b value is combined with the a value. And that's okay because we can do that as we've seen before. In this video, I'm going to look at three different cases of finding an absolute value function. The first case is if we're given the vertex and a point. So let's look at that now. Let's say that we're asked to find the rule of an absolute value function that has a vertex of -3, -5, and that passes through the point -2, -7. So remember that h and k are the x and y values of the vertex. So here, h is -3, k is -5, and then we're going to use this x and this y to solve for a. So let's start plugging in things that we know. Y equals a, x minus h plus k. We can plug in our h and our k. So we'll get y equals a, x minus a -3 turns into a +3, and then our k is -5. Now let's take our x value, so our x is -2 and our y is -7, and plug these in. This is similar to what you would have done last year in solving quadratics. So our y is -7, our x is -2, and now we can solve for a. So if we add 5 to both sides, we'll get -2 equals a times the absolute value of -2 plus 3 is 1. So -2 equals a. And now we are ready to write the rule. Y equals a is -2, x minus our h value, which is a -3, so it turns into a +3, minus 5. And there's our rule for this function. Let's take a look at a second case. Here, instead of being given the vertex and a point, we're told that an absolute value function passes through 3 points. And the 3 points are 5, -3, 4, 1, and 6, 1. The first thing to notice is that these last 2 points, 4, 1 and 6, 1, have the same y values, right? They have a y value of 1. Because absolute value functions are symmetrical across the line x equals h, that is kind of a vertical line that goes through the vertex, any 2 points with the same y value have to be the same distance from the vertex. So we know then that h, our vertex, is halfway in between 4 and 6. So if we find that midpoint by using x1 plus x2 over 2, we'll know the x value of our vertex. So let's do that here. H is x1 is 4 plus 6 over 2, which is 10 over 2, which is 5. Now notice that the other point we were given has an x value of 5. So we know then that this actually is the vertex, even though we weren't told that it was. And so now we're in the case that we were with the first example we used, where we have the vertex and we can use either of these as our second point. So let's do that. Y equals a times x minus h, which is 5, plus k, which is a -3. Let's use 4, 1 is our second point. We'd end up with the same answer regardless of which was our second point. So 1 equals a times the absolute value of 4 minus 5 minus 3. Let's add 3 to both sides, and we get 4 equals a times the absolute value of -1. The absolute value of -1 is 1, so then we get 4 equals a, and we're ready to write our rule. Y equals 4 absolute value x minus 5 minus 3. The last case that I want to look at is a little bit more complicated. Let's look at the case where we're given 3 points, none of which is the vertex, and none of which share a common y value. So here we go. We have 3 points, and this time the 3 points that we have are 0, -5, 5, 5, and 8, 3. Now, they have no common y values, and we aren't told that any of them is a vertex. So the first thing that I think to do is plot these points and just use a little sketch. So if we have 0, 5, we have 1 point there. We'll extend our x-axis a little bit. Here's the point 5, 5, and then we need 8, 3, which is about here. Now let's imagine some lines that go through these. If we have a line that's connecting these second 2 points, we can kind of see the angle, right? And we know that the other ray would have to be the similar except negative angle, right? It has to be symmetrical across the y-axis, across the line x equals h. So if we imagine kind of the same slope but going downward, it would be a line that looks like this, which means it couldn't go through this point. Whereas if we imagine the line that went through these first 2 points and extended up here, we could imagine kind of the same slope coming down this way, and we would have our symmetrical absolute value function. What that tells us is that these first 2 points are on the same ray. They're on the same side of the absolute value function. It would go up to here and then down to here, and this one is on kind of the side of the absolute value function as it's coming back down. So these two are on one ray, and this one stands by itself. Remember now that absolute value functions are 2 rays. They're 2 lines that terminate at the vertex. So we can think of these as finding the rule of a line. We know that these 2 points are on the same line. So remember, the rule of a line is y equals ax plus b, where a is y1 minus y2 over x1 minus x2. So we can find a. y1 is 5, minus y2 is a -5, so that becomes plus 5. x1 is 5, and x2 is 0. So we end up with 10 over 5, or 2. So here, to find the rule of this line, we see y equals 2x plus b. And let's keep solving it to find the whole rule of this line. We can use either of these two, sub in our x and our y, and solve for b. So -5 equals 2 times 0 plus b. So -5 equals b. And we see that the rule of the line is y equals 2x minus 5. We know a couple of things about our second ray. We know that the slope is the same slope as in the first ray, only negative. So if we're looking at ray 2, we know that a has to equal -2. So we don't even have to worry about having a second point to find our slope, because we know that from our first line. We can find the rule of this line too. Y equals -2x plus b. We have an x and a y, so we can solve for b. 3 equals -2 times 8 plus b. 3 equals -16 plus b. So we end up with, if we add 16 to both sides, we get 19 equals b. So the rule is y equals negative 2x plus 19. Now, we found these two rules, the rules of each side of the line, because where these two lines meet is the vertex. So we can use a system of equations, either using comparison or substitution or elimination, to solve and find our vertex. So if we do that over here, and I'm going to use comparison, so I have 2x minus 5 equals negative 2x plus 19. And now we can solve for x. If we add 2x to both sides, we'll get 4x minus 5 equals 19. If we add 5 to both sides, we get 4x equals 24. Divide both sides by 4, we get x equals 6. We can now use either of these rules of the line to solve for y. So we end up with y equals 2x minus 5. I'm using this one. Again, you can use either of them. You'd end up with the same answer. So y equals 2 times 6 minus 5. Y equals 12 minus 5, or y equals 7. So we know then that the vertex is the point 6, 7. Now we could be at the spot where we were in these first two cases, where we have the vertex in a point, but we've actually done more work than that because we know our a value. Our a value is the same as the slopes of these. We just have to determine whether it's a positive 2 or a negative 2. And we can imagine that this absolute value function opens down, just given where these points are, which means it has to be a is negative 2 because the absolute value function opens down. So we're ready to write the rule. Y equals negative 2, absolute value, x, here's our h and our k, minus 6 plus 7. And we're all done. I hope that helps. Thanks so much.